First off, I'd like to introduce myself. Hello, my name is Lance Zurich, and I'm the product manager for the Fischertechnik division over here at Studica. And today I'm going to give you a brief overview of the Fischertechnik STEM Prep 2.0 and STEM engineering sets. And these sets were designed to enable educators to provide students with a project-based, standards-focused curriculum program which involves inquiry, design, and problem solving. And the curriculum for each of these sets was created especially for Fischertechnik by noted educator and STEM expert Tom White. If you don't know about Tom, we're going to tell you all about him in just a little bit. But first off, we're going to move right along here. So what is STEM? Well, of course, most educators are well aware that the term STEM is an acronym, the letters of which stand for science, technology, engineering, and mathematics. Now, if you're involved in any aspect of education these days, you probably can't open your email box without seeing STEM highlighted in the subject of at least one of your daily messages. And you certainly can't read an educational journal or visit an educational conference, when we are able to visit educational conferences again, without being bombarded to references to STEM. And the reason for this is really pretty simple. To quote the Bipartisan and Congressional STEM Education Caucus in their report on the importance of STEM education, STEM education is necessary because it helps provide the scientists and engineers needed for future development. It provides the future workforce with the skills required of a high-tech world, and it builds the foundation for scientifically literate voters and citizens. Now, as such, STEM education could really be considered kind of a matter of national security. See, on every level, the world around us is changing at a frantic pace. Now, STEM education, it could be argued, enables us, both as individuals and also as a nation, to understand and keep up with these rapid changes in technology, changes which in turn are, of course, altering the demands and the scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this requires us to keep pace with the rapid developments that are occurring all around the globe, where countries such as China, India, and many others are making major investments in state-of-the-art infrastructure. And while all that is well and good, and we should of course all strive to be good citizens, some students might instead ask, well, what's in it for me? Why do I want to study engineering, or why do I want to study coding, or what have you? So let's consider what it means on the individual level. Well, first off, a few years back, the United States Department of Commerce released a set of projections for the decade leading up to 2018. Now, these projections had indicated that STEM occupations were expected to grow by 17%, compared with just 9.8% expected growth for all other occupations. Now, in March of 2017, the Office of the Chief Economist released a STEM Jobs 2017 update, which looked at how these numbers played out up to the year 2015, with 3 years still left in the initial projection, and I think we're still waiting for the final numbers. But anyways, on the whole thing. But what they found out then on the partial numbers was that while the projected STEM growth up to that point, once again 2015, was as expected up significantly, albeit a bit less than expected to be reached by 2018, they found that it was up to 14%, not quite the 17% that they were expecting overall yet, but of course it was only partway through, so they were up to 14% growth. But the actual growth for non-STEM jobs, which again they expected would eventually reach 9.8%, had instead at that point only reached a fraction of the growth that was expected, just 1.7%. So even there you can see there's really a stark difference in how STEM and non-STEM careers play out. Now, here's a statistic I like to share that should give anyone entering the job market of the future something to think about. And this comes from J.D. Chesloff in his Education Week article from March of 2013. To quote Mr. Chesloff, across the country, across all occupations, there are 3.6 people for every one job. Now in STEM fields, there's one person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising considering that the U.S. Census Bureau recently reported that the median salary for engineering majors was the highest of any profession, end quote. Now, as Chesloff goes on in his article to state, quote, supply is low and demand is high. there's a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. Well, going back to the STEM Jobs 2017 update released by the United States Department of Commerce, which I referenced just a few minutes ago, here are 3 key points mentioned in this report that are well worth keeping in mind when considering, again, the importance of STEM education to the worker. Key point number 1, quote, STEM workers command higher wages, earning, on average, 29% more than their non-STEM counterpoints in 2015, end quote. Key point 2 relates to the fact that many graduates with STEM skills may not always end up in what are strictly considered to be classic STEM jobs. These are things we'll think of first, things like scientists or engineers or what have you. Going back to the report, to quote, STEM degree holders enjoy higher earnings regardless of whether they work in STEM or non-STEM occupations, end quote. On this point, I have to mention, there was a video I saw recently on YouTube, and it was posted by the Women's Forum for the Economy and Society. And the title of the video, I think, really kind of sums up this idea nicely, and that title is, Every Company is a Tech Company. Now, what I take from that is essentially that what students want to keep in mind is that whatever a company makes these days, whatever it sells or whatever service it performs, at some point, STEM skills are required to help that company fulfill their mission. Well, continuing on, key point number 3 relates to job growth. Quote, employment in STEM occupations grew much faster than employment in non-STEM occupations over the last decade, 24.4% versus 4% respectively, and STEM occupations are projected to continue to grow by 8.9% from 2014 to 2024, compared to just 6.4% growth for non-STEM occupations. Now, with all this in mind, the trick for educators is to find methods for getting students involved with STEM, and in particular, getting them involved in the most highly in-demand technology-focused skill areas, things like engineering and coding, and doing so in a way that engages students' interest and creativity, but at the same time helps to develop the work habits, the way of approaching problems, and the skills that these students are going to need to draw on as they move forward in their careers, both academic and of course in their working lives. Now, most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results will occur and students have to discover why they occurred, or where students have to find a way to achieve a specific outcome. So how do they do this? They do this through experimentation, they do this through research, and they do this through trial and error activities. In short, they find the answers to these questions through the use of hands-on project-based learning. And that brings us, of course, to the focus of this webinar today, which is the Fischertechnik STEM Prep 2.0 and STEM engineering sets. Now, both of these sets have been designed to provide a guided, project-based learning experience, complete with detailed, standards-focused curriculum, all built around the unique Fischertechnik building system. Now, that might beg the question, so what is Fischertechnik? Well, just to provide you with a little bit of background. Fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed just to simply stack, Fischertechnik has been created with more of an engineering mindset. The core building block in the Fischertechnik system is unique in that it allows attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Now, many of the very specialized parts that are included are designed to slide together and lock in place, and these hundreds of different parts will also help students to address very specific design needs. Fischertechnik was created in 1964 by the German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was also the inventor of synchronized flash photography, and that was back in 1949, And he was also the creator of the expanding nylon wall plug, which almost everyone knows, and it's used in conjunction with a screw or a bolt to help anchor heavy objects to walls. Now, his company, the Fischer Group, still employs thousands of individuals worldwide, producing many variations of fastening devices used in building constructions, as well as numerous components used in the automotive industry. And they are also known for providing consulting services in regards to advanced manufacturing processes. I'd also like to mention that Fischertechnik was the very first construction set that enabled students and gave them the ability to build and program their own robots. And this was all using the original pre-Macintosh era Apple computers. Now, almost since its inception, Fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related subjects. And these are, of course, things like robotics, renewable energy, mechanics, optics, physics, pneumatics, and so much more. Now, Fischertechnik has also been used by numerous companies like Porsche, Daimler Chrysler, BMW, just to name a few, and I could add to that list easily, for industrial simulation and training purposes. Now, in addition, over the last few years, Fischertechnik's line of pre-assembled simulation models, one of which you see on your screen right now, have found wide adoption for demonstrating and exploring the world of IoT, which is, of course, the Internet of Things. And this is where industrial processes can be monitored and controlled from the cloud. Now, as such, with this in mind, more than just being something that students are only going to use for a year or two in their development, you can really think of Fischertechnik as being a system that's designed so that students can grow along with it. And what I mean by that is that as students progress through their academic careers, they can also progress through the levels of Fischertechnik education solutions which are available. The Fischertechnik STEM Prep 2.0 and STEM engineering sets are two of the most important members of the Fischertechnik education family. STEM Prep 2.0 is designed for exploring essential aspects of technology with a focus on physics, robotics, energy, and power. STEM engineering is designed to provide a comprehensive overview of robotics, coding, and automation systems. Now, each of these STEM-focused sets is designed to provide all of the materials that an educator is going to need, both the physical materials and the instructional materials, to enable teachers to offer a complete and daily STEM-focused classroom experience. STEM Prep 2.0 contains over 75 academic hours of curriculum material, and STEM engineering contains over 150 academic hours of curriculum material. So essentially, if you offer your students a STEM education class of a single 50-minute period each day for 5 days a week, this would provide you with enough curriculum material with the STEM Prep 2.0 set to cover a half a year, and with the STEM engineering set to cover a full academic year. Now, the curriculum for each set comes in a handy PDF format. There is a curriculum PDF specifically for the teacher to conduct the class, and also a separate PDF that can be shared with the students that helps to act as a guide for all the student activities that are going to be addressed, and it helps to keep everyone on the same page. And also, to assist new users of the Fischertechnik system, the curriculum also includes a helpful tutorial section. This section provides guidance like identifying the many types of parts included, showing how these parts fit together, and it even walks users step by step through the building of a simple model. The STEM Prep 2.0 and STEM engineering sets are also designed to be somewhat dual function. What I mean by that is that besides being designed so that educators can conduct a curriculum-centered, project-based STEM education class, they also include full-color step-by-step assembly manuals in PDF form that come from various popular Fischertechnik STEM-focused education sets. Now, these assembly manuals can, of course, be used as a reference when students will be asked to create their own original projects, which is, of course, the focus of this project-based learning setup that we're going to be talking about. But they can also be used to allow students to build all of the models shown in each of the manuals with the parts that are found in these sets. Now, in fact, the STEM engineering set allows students to build all of the models found in Fischertechnik's 3 most popular robotics sets. And the STEM Prep 2.0 allows students to build all of the models found in 8 different STEM-focused education sets. as well as the robotics BT beginner set. And we'll cover that a little bit better in more depth in just a little bit here. Now, as I mentioned at the very top of the presentation, the curriculum material found in the Fischertechnik STEM Prep 2.0 and STEM engineering sets was created by a man named Tom White. And you see a picture of Tom right there. Now, Tom is a noted educator who's been involved in STEM education since the 1970s, and he's known for designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, this is not the first time that Tom White has created curriculum based around Fischertechnik. Besides also being the creator of the curriculum used in our elementary-focused Introduction to STEM series, and our other project-based offering, which is the robotic competition set, each of which are the subject of their own webinar presentations if you had an interest in those. Besides this, Tom has also incorporated Fischertechnik in many of the educational programs that he's designed over the years. Now, Tom has often told me that he believes that Fischertechnik is the ideal construction set for any kind of engineering-based curriculum program, and he's given several reasons for this. First, he really likes that the materials can be used and reused. Things that are built can be taken apart and reassembled into something completely different. And he likes the versatility of Fischertechnik and the fact that it offers so much more economy than purchasing, let's say, an expensive piece of equipment. For example, something like a robotic arm, where students might only perform a certain number of experiments and then it, of course, sits till next year. Instead, you have something that you can essentially keep using and reusing. He also appreciates that the Fischertechnik system, with its wide assortment of very specific mechanical and structural parts and components, offers almost limitless creative opportunities for engineering design students. Now, the curriculum for both the STEM Prep 2.0 and the STEM engineering sets has been designed to address some of the most widely recognized academic standards currently in place. And by this, we mean things like the college and career readiness standards for math, for science, for reading and for writing, the NSES content standards, standards for technological literacy, ISTE standards, and the next generation science standards. Now, when Tom White put together the curriculum for these two sets, he had several goals in mind. First, based upon his own observation that various types of teachers have different strong points. For example, he sometimes will say that he sees his own strong point more as being in the creation of curriculum, things like this, more so than, let's say, conducting a lecture. Well, with this in mind, Tom focused on creating a curriculum that would provide a broad foundation of tools to enable all types of teachers to be successful in providing this class, so that they could instead focus on the needs of the students. Now, materials have been included at the beginning to familiarize new users with how the system works, as I mentioned before. And each section of the curriculum will clearly spell out how things will be covered in that unit. Essentially, everything has been designed to basically provide a turnkey solution that would provide everything teachers will need in one place. So in short, the curriculum was designed to provide a clear roadmap for both the teachers and the students, with the learning facilitated through the extensive use of projects and problems for the students to address. Now, the goal was also to enable teachers to provide students with engaging curriculum-based projects that had an authentic objective in solving real-world problems and which contain embedded academics. The detailed curriculum with each of these sets, if followed, will allow educators to provide what is essentially a standalone project-based STEM education class. Of course, as I mentioned before, each set also includes step-by-step instructions for building the various models found in some topic-focused Fischertechnik STEM sets, so you have different ways of approaching this. Now, under this project-focused model, students are told upfront what they will need to learn and understand, and they are given a real-world scenario where they will take on the role of a professional working on a team, which has been presented with a design challenge that they must devise a solution to, and they are then provided with different tools and different pathways to help them achieve this goal. Now, among other things, students will be asked to perform research, and by this we mean research both inside and outside of class. And students will also have to learn the documentation process, and this will include things like creating a design brief or maintaining a digital engineering journal and things of this nature. And students are also going to be required to collect data. So because of this, they're going to learn firsthand how data acquisition works, how to process data, how to put data into graphs and other formats, and so on. Students are given a technical literacy task that is driven by the project. And fulfilling this task will require them to gain the knowledge and the tools needed to address it through research and exploration. Students will perform a series of specially designed enabling activities through which they will acquire the necessary science, math, and tech-based skills to help them successfully address the project at hand. They're going to devise solutions to their tasks, and they're going to create prototypes, of course, using the advanced Fischertechnik modeling system. Now, where required, students will also create and install the programs needed to control these prototypes. Again, they're going to document every step of the entire process, and they have to formally present their findings, including a demonstration of the prototype. Now at this point, let's take a look at the sets themselves, and we'll begin with the Fischertechnik STEM Prep 2.0, a picture of which you see on your screen right now. Now the prep in the name, like the term STEM, is an acronym. In this case, it stands for physics, robotics, energy, and power, which are the subjects focused on in this set. Each of these sets is designed to be used by a team of 2 students at a time. The set contains 2,260 parts and components, and this includes the ROBO Pro LT software, the BT or Bluetooth smart controller, an electronic module, a pullback motor, a solar motor, an excess motor, a mini motor, a compressor, 2 solar modules, a gold cap energy storage unit, an NTC resistor, a photo transistor, an LED, 2 rainbow LEDs, and many other parts, all of which come packed in a sturdy plastic Ratnell storage box. The project themes addressed in the STEM Prep 2.0 set include the following areas: sketching and documentation, simple machines, mechanical systems, structures, the conversion and the storage of energy, electronics, optics, digital communication, and programming control systems. And once again, this has been designed to provide enough curriculum materials to basically cover 75 plus academic hours. Now, the STEM Prep 2.0 set also includes step-by-step pictorial instructions culled from 9 individual Fischertechnik STEM focused sets, the names of which you see on the screen: the drive systems, eco energy, which focuses on renewable energy, pneumatics, mechanics, physics 1 and physics 2, electronics, optics and light, and the robotics BT beginner set. Now, the one thing I will mention is that aside from 5 models shown in the instructions for the eco energy set, which in this case incorporate an optional fuel cell add-on, which can be purchased separately if one chose. Otherwise, all of the other 118 models shown in these instructions, which you see on your screen, can be built with the parts found in this one box. Now, with this in mind, even if you didn't wish to use the curriculum for whatever reason, the STEM Prep 2.0 set would still be a convenient and affordable way to have the building and learning power from these 9 sets in one box. Next, we're going to look at the Fischertechnik STEM engineering set, which you see on your screen now. Now, this set can be used as either a follow-up to the Fischertechnik STEM Prep 2.0, or it can be used entirely on its own. And it's designed to provide students with a comprehensive overview of robotics, coding, and automation systems. Now, in this case, the set is designed to be used by teams of 2 to possibly 4 students at a time. Now, if you remember with the other set, I said it's 2 students at a time, and this one is 2 to 4. The difference here is because the projects in this set are more elaborate, and they're going to involve many more steps than those found in the STEM Prep 2.0 curriculum. And with this in mind, it's easier to keep a higher number of students actively engaged with the research, the building, the programming, and all the other tasks that are going to be required. Getting back to the set, The box itself contains 890 parts and components, and this includes things like the ROBO Pro software, which is the full version of ROBO Pro, the robotics TXT controller, which is slim size. It's got Bluetooth, Wi-Fi capability, full color touchscreen, all sorts of other nice features. It also includes a Fischertechnik AccuSet, which is a rechargeable battery pack with the charging unit. It includes 2 encoder motors, a compressor, 2 photo transistors, 2 XS motors, a mini motor, 6 push-button switches, a color sensor, an NTC resistor, 3 LEDs, 2 solenoid valves, a vacuum suction device, and hundreds of other parts, of course, all once again packed in a sturdy Gratnell storage box. The project themes in the curriculum for the STEM engineering set address the following areas: sketching and documentation, basic electricity, programming, sensing and vision systems, mobile robotics, actuators, and the fundamentals of automation and robotics. And in this case, again, the curriculum is designed to cover 150 plus academic hours. Now, there are also activities included to address the following areas that come up during the course of the curriculum, and the same thing will show up in the STEM prep. I realize now a slide was missing there, but you'll cover things like, for example, with the STEM engineering, things like sketching, schematics, Ohm's law and power, an introduction to using the ROBO Pro software, an introduction to using the TXT controller, working with flowcharts, open loop and closed loop programming, working with digital branching, edge triggered versus level triggered, logic gates, combinational logic, analog branching, variables, subprograms, data, sensors such as the digital switch and the digital photo transistor, working with analog sensors such as the NTC resistor or the color sensor, an introduction to working with the camera attachment, using the camera attachment to detect motion, working with color detection, creating a ball finder, which in this case involves using the camera as a vision system on the robot, working with the line tool, working with the encoder motors, building the control panel, working with pneumatics, positions, recording robotic positions, and utilizing existing programs and subprograms. Now, this set also includes step-by-step assembly instructions found in the following 3 Fischertechnik robotics sets: the Robotics TXT Advanced, the Robotics and Electro-Pneumatics set, and the Robotics in Industry set. Now, once again, if you wanted to work outside of the curriculum, if you just wanted to put the curriculum aside for whatever reason, this set will still contain all the parts, the software, the controller, the power supply, everything else that you're going to need so that you can build any of the 22 models found in these 3 sets that you see on your screen. And this includes things like color sorting machines, pinball machine simulation, mobile robotics, robotic arms, and things of this nature. Now, at this point, as we've touched upon what is covered by each of these sets, I think it's going to be useful to show you exactly how the curriculum for both the STEM Prep 2.0 and the STEM Engineering sets is structured. Each unit of both the STEM Prep 2.0 and the STEM Engineering curriculum contains a roadmap of sorts where each of the following elements are addressed: the purpose, the concepts, the student deliverables, assessment and evaluation materials, an outline, the standards to be addressed, the authentic project scenario, a daily teaching plan, supporting activities are included, as are resources. Now, to put this into better context, let's look at the curriculum that accompanies the STEM engineering set. Now, again, while we are going to focus on material found in this particular set for the purpose of this presentation, please keep in mind that the structure of the units and how subjects in both the STEM Prep 2.0 and the STEM engineering curriculum is addressed is essentially going to be the same for both. So when you see me talk about things like the purpose or the concepts or the student deliverables or what have you, this again applies to the way that both sets are structured. First off, we're going to start off with the table of contents for the STEM engineering set, which you see on your screen now. Now, the first thing I'd like you to note is that before we get into any of the specific units, things like you'll see on this page, we have the units listed for sketching and documentation and basic electricity. Before we get into any of that, there is a section right up front designed to help any new users of the Fischertechnik system to quickly get up to speed. Again, The core building blocks used in the Fischertechnik system are designed to attach from all 6 sides, and many of the other parts are designed for very specific purposes. Now, as this is going to be a little bit different than the simple stacking construction of many other building sets you may have worked with, we've included this section right up front to help increase your comfort with the system as a teacher, and of course your students' comfort, and allowing them, everybody, to get the most out of their building experience and their learning experience. So we want you to go over all this first, then you're going to be the most successful with material that comes after. There's going to be a section, for example, showing specifically how the parts fit together and discussing the pin and groove assembly method that's used. There is a section showing you how to identify the different parts, from the core building blocks to more specialized parts, things like clip axles, girders, rivets, angle pieces, and much more. There is a section that shows you a picture of every part contained in each set, along with the name of the part number, and the quantity of the part that are included. Now, this can be especially useful if you ever wish to order additional quantities of any parts to add to your assortment, or of course, if you ever need to get any replacement pieces. And for those educators who might be new to an approach such as this, there's also a chapter included discussing how to go about conducting a project-based STEM education class, because once again, it's a little bit different. Now, on that note, let's jump ahead to a sample unit just to explore the structure that we just went over. Now, this unit, as you will see from the picture on your screen, is focused on programming. Now, the picture that you see at the top of the page, the sample page, is a graphic representation of the ROBO software that students are going to be using to do their programming with this. Now, as you'll see in this close-up, of course, ROBO is designed to utilize icons that represent the different actions that a robot must perform, or, a robot or a machine or what have you. And in this case, students arrange them in a flowchart style manner to create the program for each of these robotic or automated models. Now, the nice thing about using graphic programming software such as ROBO for programming is that it allows students who may not have any prior experience with programming of any sort to quickly become comfortable with doing so. But at the same time, it also helps to familiarize all students with the core concepts that are going to be found in all types of programming. Now, going back to our main page, as you will see right under the unit title, the first thing that you encounter in each unit is a section entitled "The Purpose of the Project." And this is the section that seeks to clearly spell out to students the answer to that eternal question. I'm sure everybody's heard it. Why are we doing this? See, too often in the past, students might encounter subject matter that didn't seem to have any relevance to them. I know myself, when I encountered things like trigonometry in high school, it didn't make a lot of sense to me because I didn't see the applicability. Well, here we're trying to show them what the applicability is so that they get an idea of why it's important. After this, you see the concepts to be addressed in this unit. And these can be thought of as the big ideas that students should take from this project that will be essential for them to understand and utilize not only today, but also to draw upon as they move forward in STEM fields of study, and of course, we hope STEM-related careers. Now, after this, we get into the outline. In this section, we drill down more specifically to what will be addressed in this unit. Now, again, as this particular section is focused on programming, you're going to see that in this section here we're touching upon areas such as the methods for writing programs, for example, flow charts, word problems, and so on. Program characteristics, things like open loop or closed loop. We get into branching, digital branching, analog, subprograms, and so on. Now, after that, we come to a section where each of the specific standards to be met by the particular project unit we're looking at are spelled out, which of course will help provide the educational justification for the projects the students are going to be doing. Now, we often get asked about the standards, if we include state-specific standards and what have you. Of course, it's impossible to include all the standards that have been created by individual states and school districts and what have you. So instead, what we've done is we've taken the most universally accepted and used standards that are currently in place in the United States. So in this case, we include things like the college and career readiness math standards, as well as the writing standards for literacy in history, social studies, science, and technical subjects. Next, we have science standards, beginning with the NSES content standards for K-12, and the standards for technological literacy, which are followed by the ISTE Technology Foundation standards for students and the next generation science standards. After that is an assessment section, which includes links to both general course rubrics, as well as rubrics which are going to be related to the specific subject unit. After that, we have what's called the essential question. And this can be thought of as a broad major idea that's going to be explored in this unit. Now, in this particular case, the question being put forth is, how can we make decisions electronically and remove the need for human intervention? After this, we get what might be considered the centerpiece of each of these units, and this is the student scenario. Now, the student scenario for each unit gives the students an opportunity to explore the unit's essential question, and this occurs in the form of a real-world problem that students are given to solve, and it helps to provide a tangible example of why the subject matter being explored is both relevant and important to understand. Now, in this particular example, again from the programming unit, students are asked to assume the role of a controller/programmer who happens to be working at a programming company that specializes in designing elevators and writing the control packages required for their clients. Now, working in small groups, which again is going to be the way that all the projects in this curriculum are approached, the students are going to be asked to work together to design an elevator, which is going to have certain parameters to how the design is going to be done, and then must be able to perform certain functions. One example might be if the elevator was at rest on a floor somewhere in the middle and someone on an upper floor was pushing a call button at the same time that someone on a lower floor is pushing a call button, you basically have to create a protocol in the program for where it goes first. So that's all going to be part of this here. So again, in this student scenario, the client requirements are all going to be spelled out, and the students will be required to, again, design an elevator, create a program to address these specific requirements, build the actual elevator prototype using, of course, Fischertechnik, and at the end of the unit, they're going to prepare a presentation for these fictional clients that includes both a demonstration of the prototype and the program they've created in action. The student scenario is followed by the daily plan. And the daily plan is what acts as essentially the roadmap of sorts, and it clearly lays out the expectations that students work through the project that's given in the student scenario. Each day of the daily plan acts as a guideline, and it spells out specifically what the students will look at today and what they need to accomplish. Now, you'll see that as different concepts are addressed, students are provided with helpful links that come up throughout the curriculum, which will give them more information. For example, here they will have links showing them what's required in design brief, or that they're going to be asked to create, or what kind of information they're going to need to keep track of in the digital engineering notebook, things of this nature. It's all spelled out in the various links, or even how to install and use the ROBO programming software. Now we're going to look at some of these links a little bit later. But anyway, again, each day of the plan contains a different task that has to be addressed, a different activity that needs to be performed, or a different question that needs to be answered. For example, now if you look closely at the bottom of the page that I have up here on the screen, that would be day 7, you'll see that we have a discussion topic listed. This discussion topic happens to be, how does my dishwasher know when the dishes are clean? Now, of course, everyone knows a dishwasher doesn't judge or comprehend when dishes are clean. Instead, a dishwasher is programmed a certain way to go through a certain cycles and for a certain period of time. And in this case, the teacher can lead a discussion where this idea can be explored and addressed. Now, other things covered in this unit, for example, will include things like how data is taken from a sensor and recorded, or how files can be taken from the ROBO programming format, put into an Excel format to be worked on, and then put back into RoboPro, or even things like working on robotic positioning. Now, I will say this is one of the longer units in the curriculum. It happens to continue for about a period of 35 days total. In any case, as students work through the daily plan and on their answer to the student scenario, once again, they're going to be required to perform research. They're going to be required to do trial and error experimentation. They, of course, again, have to document the entire process. And this means, again, maintaining a design notebook and a digital engineering journal. They're going to design and build a working prototype using Fischertechnik. Now, again, if the model is automated or robotic, as it is in this particular case of the elevator scenario, the students will also have to design the program that controls the model. Now, putting everything together, each student group will, at the end of each of these units, create and deliver a presentation of their prototype in action. Now, the idea here is, of course, that each day builds on the one before it, and each activity is subsequently more complex, and along the way provides more of the information that students are going to need to draw on to successfully complete the particular project. The idea behind this is that it really helps to reinforce all the concepts, and it ties everything together in a very organic and meaningful manner. Now, there are also various supplemental materials included at the end of every unit. Now, depending on the particular unit, this can include vocabulary words, which are usually included. It can include carefully selected web-based resources. It could include Word documents, PDF files, PowerPoints, video links, what have you. Once again, each unit of the curriculum for both the STEM Prep 2.0 and the STEM engineering sets will follow the same structures we've just looked at. Again, including the standards, the rubrics, the daily plan, the resources, and so on. Now, as I mentioned before, there are also numerous links throughout the curriculum that are designed to provide more guidance on specific topics as they come up. Now, besides being linked this way throughout the curriculum, these sections are also all collected in one place at the very end of the curriculum. Now, once again, using the STEM engineering curriculum as an example, there are links provided detailing information on such things as what's going to be required in that design brief or in the digital engineering notebook, a section on schematic drawings, another on Ohm's law and power, a section showing how to program a robot to detect motion using camera attachment, working with digital branching, with flowcharts, open and closed loop programs, combinational logic, working with the ROBO Pro software, robotic positioning, working with sensors, working with data, learning to use vision systems, working with subprograms, and so on. Now, there's also a section where all of the rubrics for the curriculum are collected in one place, both the general course rubrics, as you see here, as well as the specific rubrics, for each individual project theme unit. And finally, this is followed by a section containing the step-by-step assembly instructions in PDF format. Now, once again, the STEM Prep curriculum will share this same structure, just with a focus, of course, on some different subject areas. Now, at this point, I'd like to share a few photos with you of just one of the schools currently using the Fischertechnik STEM Prep and STEM engineering sets. And in this particular case, the school is Westfield Technical Academy, which is located in Westfield, Massachusetts, where the program is being conducted by Dave Roberts, who happens to be the science teacher over at Westfield. Now, what you will see in these pictures are the students as they address the very first hands-on challenge, which is presented in the curriculum for the STEM Prep 2.0 set, and that's of designing and building a prototype of a braking system as would be found on a racing bicycle. Now, again, students work in small groups. Once again, with STEM Prep 2.0, we recommend one set per each group of 2 students, but with the STEM engineering set, once again, because the nature of the projects are more involved, you can expand this group up to 3 to 4 students. Now, as you will see from the photos, that while the students are all working on the exact same project, that there is no one right way, there's no single solution for addressing the design challenge given in each unit student scenario. Instead, what you're going to see is some of the students will design and build prototypes that work very smoothly and efficiently, and that others are going to create models that might be too elaborate and they really need more refinement to be practical. But in any case, the goal is, of course, to see how well the students synthesize all the concepts they've learned, and how through working in small teams, how well they can use their creativity and problem-solving skills working together to make something that will most effectively and efficiently answer the criteria put forth in the student scenario. Now, I'd also like to mention another benefit of the STEM prep and STEM engineering sets, although it happens to be a somewhat unintentional one. Excuse me. Now, a large segment of the students at Westfield Technical Academy are classified as ESL students, which means English as a second language. And they originally came to the US, in this case, from Russia and the Ukraine. Now, in Massachusetts, teachers are required to take classes in ELL, which is English language learning, to help them meet the needs of students such as this. Now, Dave Roberts, who again, as I mentioned, is the teacher in charge of the Fischertechnik STEM programs over at Westfield, told me that he has attended 3 different ELL training classes. And all 3 of these ELL training classes have in particular highlighted project-based learning as an important learning tool for ESL students. Now, the reason for this is because design is really considered sort of a universal language. And working through the curriculum in this hands-on fashion helps students not only to learn essential STEM-related concepts, but it also aids in building their English language skills because it helps them to make the connection to actual processes that they can see and understand. Again, what I've shared here are just a sample of some of the ways that students can address this particular design challenge. Now, again, as I stated before, each subsequent unit will require more sophisticated designs, and each will, of course, build on what has come before. So at this point, let's just very quickly summarize what we've covered here. Each Fischertechnik STEM Prep 2.0 and STEM engineering set contains everything you're going to need. It contains all of the parts, contains the software, all of the assembly instructions, and again, the complete day-by-day curriculum. And the curriculum included in each set is yours to use this year, next year, and for many years after that. There are no additional fees, there are no subscription charges, there are no charges for accessing our site to download the curriculum, none of that. Everything you need is included. And again, it's all reusable. You can build a model, perform the experiments, take it apart, and move on to the next one. And of course, if you ever did decide you need any odd parts to augment the projects the students are doing, if you need replacement pieces, whatever, you can purchase any of the parts individually in whatever quantity you choose directly from our website. Again, the Fischertechnik STEM Prep 2.0 and STEM engineering sets are designed to make it easy for educators from any kind of background, even a non-STEM background, to offer a hands-on project-based learning experience to their students. And once again, project-based learning is what experts agree is one of the most effective methods known for teaching STEM concepts. Again, the STEM Prep 2.0 set comes with over 2,200 parts components, includes day-by-day project-based curriculum PDFs for both students and teachers, with over 75 academic hours of materials, as well as step-by-step assembly instructions from 9 popular Fischertechnik education focus sets for building 118 different models. The pricing on this set starts at just $899 per set, with, of course, classroom pricing quotes available upon request. And the STEM engineering set, shown here, includes 890 parts components, again, including the programming software, the full-color touchscreen TXT controller, sensors, motors, many parts, so much more, as well as student and teacher curriculum PDFs featuring over 150 academic hours material, and the full-color step-by-step assembly manuals from the 3 most popular Fischertechnik robotics sets. The pricing on this set starts at just $939 per set, and again, please contact us directly for classroom pricing quotes. So on this note, you may have questions, and if you do, this would be the time to type them in. If you could use either your chat window located on the Zoom toolbar under the ellipses, or you can use the question and answer window, which I think is in the middle of the Zoom toolbar if yours looks like mine. So either of those methods, if you have anything you'd like to know, feel free to type it in. I will also mention, while you may or may not be typing, that if you do have any questions that you might want to ask me at a later time, you can also email me directly. It will go directly to me. You can email me at LanceZ, that's LANCEZ, that's Z like zebra, so LanceZ studica.com, studica.com. You can send me an email, and I promise to get back to you with answers to any questions you might have, and I'm happy to tell you about any aspect of Fischertechnik, either what we're talking about today or any of the other products that we offer, any of the other education solutions we offer. So if that does come up, please go ahead and do that. So I see no questions coming up, so I will go going once, going twice. And on this note, I'd like to thank you for taking the time to attend our presentation today. So again, if you'd like to know more about either the Fischertechnik STEM Prep 2.0 or the STEM Engineering set, if you would like to request a quote, or if you'd like to speak to one of our dedicated educational representatives, you can just call us at one of the numbers you see on your screen right now. If you're located in the United States, of course, you can call us Studica USA. Our toll-free number is 888-561-7521. If you happen to be located in Canada, you can call our Canadian office at 800-561-7520. Once again, all toll-free numbers. If you'd like to find out more information about either of these two sets or any of the other Fischertechnik education options, you can of course go to our website, www.studica.com/Fischertechnik-education. If you go to that page, type in that URL, or just do a search for Fischertechnik on the Studica website, you'll come up to a group of pages that have lots of information on all the individual products, the spare parts, the different teaching options, our simulation models, all of that. So feel free to go there. Or of course, if you have any questions or you'd like to know anything else, you can either email me directly, as I mentioned, LanceZ, L-A-N-C-E-Z @studica.com, or you can email us at info, that's easy to remember, info @studica.com. Once again, thank you very much for attending, and I'd like to say have a great afternoon, stay safe, and we'll talk to you soon.